Hello everyone, welcome to Engineering Today, and we're back with some interesting updates. Let's start with our favorite, SpaceX news. SpaceX's 21st NASA Commercial Resupply Services (CRS) launch will commence on the 5th of December, Saturday, no earlier than 11:39 a.m. Eastern Time. CRS-21 launch will be an upgraded Cargo Dragon spacecraft. Cargo Dragon 2 will also dock with the International Space Station using a smaller docking port that, however, will hinder in the conveying of cargo inside ISS. SpaceX drone ship, Of Course I Still Love You, has departed from Port Canaveral for a Cargo Dragon spacecraft's Falcon 9 launch. NASA has given 6 CRS-2 contracts to 3 space agencies, including SpaceX, to cover International Space Station operations within 2025. Although Cargo Dragon 2's launch will be more costlier than before, yet NASA takes it as a reasonable choice. SpaceX has explained that cost increases as a result of their rising poise and better consciousness of their competition with other space agencies. NASA has granted SpaceX permission to reuse Cargo Dragon spacecraft to launch astronauts in March 2021. NASA seems to rely on SpaceX's reusable Falcon 9 rockets with CRS-21. So they allowed SpaceX to reuse Falcon 9 booster B-1058 on Cargo Dragon 2's first flight. If CRS-21 launches successfully, then it will be another milestone for SpaceX. And in the near future, SpaceX will use these same boosters for their commercial clients. CRS-21 launch will be the first occasion in which NASA has allowed SpaceX to use a booster that was not used in the NASA missions before. This shows that NASA has great faith in Elon Musk's company. SpaceX's B-1058 booster has flown 2 more commercial missions before, once carrying a South Korean communication satellite in July, and other in October carrying Starlink satellites. This launch will be creating a history for the first time. A new spacecraft has been powered by a flight-proven Falcon 9 booster. Let's look into an update from Japan. Japan launches JDRS-1 optical data relay satellite. On the 29th of November, Sunday, at 2:25 a.m. Eastern Standard Time, Japan launched a satellite which carried laser relay technology into space for transferring data at higher speeds from military and civilian Earth observation satellite. Using an H-2A rocket made by Mitsubishi Heavy Industries (MHI), the communications data relay satellite was launched from the Tanegashima Space Center in southern Japan and deployed in geostationary orbit. The satellite will help in procuring data by monitoring the Earth for global warming and assisting in disaster response after calamitous events such as hurricanes, landslides, earthquakes, etc. The JDRS-1 will relay optical and data radar from Japan's information gathering satellites, IGS, and relevant data from orbiting satellites to Earth. Most of the features of satellite were kept confidential, as it's partially a military mission. Mitsubishi Heavy Industries confirmed mission success and separation of JDRS-1 just a couple hours after launch. MHI announced the successful launch on Twitter, adding that the satellite had separated from the upper stage of the rocket. According to their statement, the satellite will make its way to geostationary orbit for a 10-year mission. It was confirmed that the rocket flew as planned, MHI said. JDRS-1 launch was the 43rd of the 4 types of the H-2A rocket, which is 100% successful. Laser Utilizing Communication System, LUCAS, developed by Japan Aerospace Exploration Agency, JAXA, is being carried by the new satellite, JDRS-1. JAXA said that LUCAS uses infrared light to provide inter-satellite links at speeds of up to 1.8 gigabytes per second, which is 7 times faster than the current standard of sending information by radio waves. JAXA also said LUCAS would allow for future increase in data transmission capacity and immediacy requirements in low Earth orbit vehicle. The JDRS satellite was jointly developed by JAXA and the Government of Japan. The Cabinet Satellite Intelligence Center owns and operates the satellite. JAXA will control the optical data relay function. LUCAS will fly to geostationary orbit, which allows it to rotate approximately 22,000 miles above the equator. It will have a continuous view over the Asia-Pacific area. The satellite will relay data between Japanese satellites and ground stations. This will permit speedier data transmission. Japan's upcoming satellites will be Advanced Land Observation Satellites for observation of our planet. ALOS-3 and ALOS-4 will be the two variants proficient in operating the full relay technology of JDRS-1. ALOS-3 is expected to launch in 2021. Let's move to our last update for today as China pushes ahead with Super Heavy Lift Long March 9. Zhu Honglang, Secretary General of the China National Space Administration, said at the Wenchang International Aerospace Forum on the 24th of November that the Long March 9 is under development with a test launch planned for around 2030. After Chang'e 5 lunar sample return mission was launched from the Wenchang spaceport on the 24th of November, then Zhu said this: China is aiming to use this Long March 9 Super Heavy launch vehicle for crewed moon missions. They're also planning for deep space voyages using robots. The Chang'e 5 lunar sample return mission launched by China on Tuesday used the largest rocket they've made till now. This rocket was the Long March 5, which stood 57 meters tall and weighed about 878 metric tons. According to report, Long March 9 could easily carry payloads of about 4,140 metric tons. It will reach a height of 93 meters. It will have a core booster measuring 10-meter diameter and 4 side boosters with 5-meter diameter. The Long March 9 is designed to lift about 140 tons to low Earth orbit (LEO) or 50 tons to space beyond LEO. Zhu Honglang said that China is developing a reusable Earth space transportation vehicle to perk up Chinese approach towards space. In September, China launched an inexplicable, reusable experimental spacecraft. China Aerospace Science and Technology Corporation (CASC), a large state-owned enterprise and the China's main space contractor, presented the Space Transportation Roadmap, showing the aim to develop all of China's launch vehicles reusable by the year 2035. The Long March 9 is expected to be used in missions such as single rocket Mars sample return. Building a solar power project in space is expected to be another mission for Long March 9 rocket. At the International Astronautical Congress Cyberspace Edition, it was disclosed that China has made advancements in the development of high-thrust engines that are necessary to power the Long March 9. The China Academy of Launch Vehicle Technology (CALT), an institute belonging to the China Aerospace Science and Technology Corporation, developed the Long March 9 launcher. Hui Chen of the Xi'an Aerospace Propulsion Institute said that the combination of the first YF-130 kerosene liquid oxygen engine was completed last year and ready for hot fire test operation. The equipment used in Long March 9 consists of a high-pressure and easy-flow main liquid oxygen valve, high-power, high-efficiency turbopumps, wide-range thrust regulators, and high-pressure gas generators. In the first stage of the launcher, 4 YF-130 dual-nozzle 500 tons thrust engines have been used. China Academy of Launch Vehicle Technology planned about a heavy-lift launch vehicle using 3 5-meter diameter first-stage cores and groups of YF-100K engines for using it in crewed lunar missions. Another private space agency of China, Galactic Energy, just began developing a launcher of medium range. The Pallas 1, scheduled to launch in the year 2022, will use kerosene and liquid oxygen and can be capable of vertical takeoff, vertical landing. Landspace aims to test launch the Zhuk 2 in 2021 before developing it to a variable thrust engine, vertical takeoff, vertical landing first stage. It's also using the same methane and liquid oxygen fuel. According to the report, China Aerospace Science and Technology Corporation's first launch vehicle with a reusable first stage will be the Long March 8. The first flight model has already been delivered to Wenchang Launchpad and prepared a test flight. The 20th December 2020, Sunday, is the date set for launching Long March 8. Thanks for watching. Please subscribe for more videos like this. Hit the like button if you find the video interesting, and kindly provide your valuable feedback in the comment section. This will help us to improve.